Section 3.4.21-T. The accompanying data represent the miles per gallon of a random sample of cars with a 3-cylinder 1.0-liter engine. So here's the data. For Part A, we want to be able to compute the z-score corresponding to the individual who obtained 36.3 miles per gallon and interpret this result. So before we do anything, we need to be able to pull this data up in StatCrunch. So here's the question, here's the icon for the data, and then we're going to go ahead and then open this data up in StatCrunch. And the reason why we're opening it up in StatCrunch is because what we want to do is we want to be able to generate the mean and the standard deviation of this particular column. So what we're going to do is we're going to go to Stat and then select Summary Stat and then go to Columns. And then we're going to select our column. And then we want to select our mean and our standard deviation. So I'm going to go ahead and copy that information. So this is how you're going to be able to generate your mean and your standard deviation, or you can do it by hand. But that's why we have StatCrunch in this scenario, is to be able to then be able to get this information quickly. So now we can see that the data value, so it's saying here that what we did is we obtained first, we want to be able to obtain an individual who obtained 36.3 miles per gallon. So we're using that as the X data value. So X is going to equal 36.3. Our data, which is our mean, so keep in mind that X bar represents our sample mean, okay? And so that is 38.75. So X bar is 38.75. And then the sample standard deviation, rounded to 3 decimal places, is 3.401. Now that we have this information, we can plug it into our z-score formula to solve for the z-score. So again, we know that X represents 36.3 minus the sample mean, which is 38.75. And then we're dividing it by the sample standard deviation, which is 3.401. And so now what we're going to do is we're getting a z-score of negative 0.72. And you always round that to 2 decimal places for your z-score. Next, in Part B, we want to be able to determine the quartiles. So how do we do that? Well, we can go back to StatCrunch, okay, and we can determine the quartiles. Now, when we have a lot of data, I know that at the beginning, we need to know how to do this by hand. So we need to know how to find the quartiles by hand. But now, if we use StatCrunch, this can help us determine the quartiles a lot quicker. So we're going to go to Summary Stat like we did before and select Columns. We're going to select our column title for variable 1. And then what we're going to do is, if you scroll down here a little bit, okay, you can see that we have our median, we have Q1, Q3. So you can see here that our mean, okay, is going to represent our average of what we just found up here. So we're not going to need to do that. We already got our standard deviation. But the median represents quartile 2. And then we also have to find quartile 1 and then quartile 3 because we want to determine the quartiles for that data. So remember that the median is quartile 2, quartile 1, and quartile 3 because that's what the question is asking us to determine. So we're going to select Compute. So let's go ahead and do that and copy that data into our table here. So the median, again, represents our quartile 2. So quartile 2 is 38.4 miles per gallon. And then we have quartile 1, which is 36.85 miles per gallon. And then we have quartile 3, which is 40.85 miles per gallon. So now we've answered the question for Part 3, again by using StatCrunch. Okay, so now what we're going to do is we're going to compute and interpret the interquartile range. Now remember, in order to compute the interquartile range, we're using the following data from above. We know that we need quartile 1, which is 36.85, and we also need quartile 3, which is 40.85. And then we're going to use our formula to find that. Well, the interquartile range is taking quartile 3 and subtracting quartile 1. So 40.85 minus 36.85 gives us 4. That's 4 miles per gallon. And now in part D, we want to be able to determine the lower and upper fences. And then, are there any outliers? So, in order to obtain the lower fence, okay, we're looking at quartile 1. So quartile 1 represents 36.85. And let me go ahead and put that in there. So that's quartile 1. And then our interquartile range is 4. So the lower fence is taking quartile 1, which is 36.85, minus 1.5 times the interquartile range, which is 4, which gives us 30.85 for the lower fence. Now for the upper fence, we're using quartile 3 to be 40.85, and again, the interquartile range is 4. So the upper fence is taking 40.85 plus 1.5 times 4 to give us 46.85. And then what we would do is, we would then use this information from this data up here, and I'm going to copy that and then bring it down here before we can figure out if there is an outlier. Okay, so I'm going to highlight anything in purple that's an outlier. So everything that's either outside of 30.85, so are there any numbers that are below 30.85? We don't see that. Okay, now, so therefore there's nothing below the lower fence. Now, is there anything above 46.85? Well, if we take a look at our data values, we do have one here that is 47.6. And are there any other values? There isn't. So therefore, a data point is considered an outlier using this method if it is less than the lower fence or greater than the upper fence. And notice that from our data, the largest data value, which was 47.6, is greater than the upper fence, 46.85. So therefore, this number is an outlier.